Hi everyone, my name is Patrick Ollerton. I'm the product manager for PTC Modeler. Very pleased today to be able to talk you through the new features that we have in PTC Modeler 10.1. So let's get into it. There's the summary slide. The product was released at the end of July 2024. So the main highlights are SysML 2.0, the new standard for systems modeling, a whole range of new features that we'll describe in detail, some usability enhancements with OSLC capabilities, a change to how we deploy SQL Server to improve our enterprise readiness, support for MathWorks Simulink, rebranding that you will have noticed already, and also ISO 26262 certification. So we'll cover all of those topics in a little bit more detail. So first of all, rebranding. Many of you will already be aware that our previous name, Windchill Modeler, has gone. We've been renamed, rebranded to PTC Modeler, which is a clearer kind of naming and helps to distinguish ourselves from the Windchill PLM platform. So you'll see that reflected in the software, the documentation, our web pages, and so on. Okay, so let's talk about SysML 2.0. So this is the main set of capabilities delivered in 10.1. First of all, we have some usability enhancements, really refining capabilities we've delivered before. And the first one is around package filtering, where we can hide element types in packages to provide a more focused view for our users. So we've improved the user experience with this user interface. The buttons are now more responsive and it understands when you make changes. So some small usability improvements, but really help to make that more usable tool and much easier to use. As we've implemented more of SysML 2.0, we've overhauled and improved our context menus, the right-click menu that you can see here. So we've aligned the different menu items with the structure of the SysML2 standard itself. So items are organized by requirements, by structural types, by behavioral elements, and so on. So it's much easier for users to find elements very quickly and easily, and it aligns with the structure of SysML2 that they're already familiar with. Accordingly as well, we have the enhancements to our toolbars for our main SysML2 diagram. We've added action modeling that we'll talk about in a second, and you can see the new icons, the new buttons and actions that we've added there. So although SysML2 is a broad language with a lot of capabilities, we'll have to continue to keep enhancing this toolbar to make sure that we can represent as much of SysML as we choose to, and ensure that the user experience is still as good as possible. We've provided some extra capabilities around package modeling. So this allows you, and packages are used to organize and structure models. So they help to break up complex models, provide organizational structure for the model elements, but they also provide the namespace, the scope of model elements. So they play an important role, and package modeling is a useful tool to be able to understand that high-level hierarchy of packages, the relationships between packages, and also, as you see in the graphic at the bottom, you can see membership elements. So the use case displayed there is owned by the package above it, and that's denoted by the link relationship between those symbols. So we can drag packages from the package browser, we can create packages using the toolbar and the context menu, and we can display containment as I just described in that graphic at the bottom. So package modeling is now more or less complete, and we can continue to look at some of the additional capabilities that are enhancements to what we had. Here we can see some structural modeling, we see some parts that are connected. And in 10.1, we can now display the membership relationships using the link notation that you can see in the graphic. So the line with the filled in symbol on the end is one example of that. That's the composite feature membership. And this works in parallel with the other type of notation. We can display the same relationship using a nesting graphical notation. So we support both types of ways of representing the same hierarchical relationships. We've also implemented flow connections, and these are relationships, links between items that are used to transfer elements between other elements. So that could be coolant, fuel, an electrical charge. So there's typically a source, an output, and a target that acts as an input. And we can optionally send a message with some information between those two elements as well. So in the example we see there, we have a vehicle engine that's sending some coolant onto a cooling system and into a thermostat where the temperature will get read. Another enhancement to structural modeling are binding connections. So this allows you to assert that two features of a model are equivalent and have the same values. So this is a good way of keeping items sort of in synchronization together when they should be acting as the same. So all of these features complete the different aspects of logical structure modeling from SysML2. Another nice usability feature that we've added are some user assistance information pop-ups. So we can see an example there. And this is the first of several guiding tools that we'll implement over the releases of the next few releases to help guide the user when they've performed some modeling that doesn't align with the SysML2 standard. And we can then guide the user on what to do in certain cases to resolve and correct the model. So in this example, an element is shown out of context. So it looks like it's owned by another item, but in fact, it is a member, a feature of an item somewhere else. So it's important that the user is aware of that when it's displayed graphically in this way. So there are the usability enhancements and completing features that we have for what we've implemented in Modeler 10.0. In Modeler 10.1, we've started to implement system behavior capabilities. So if we look at an overall MBSE or systems engineering process, the capabilities that we have already in Modeler 10.1 deliver on the first few steps here. We're able to define requirements, system scope, system functions, and system architecture. So in Modeler 10.1, the next step is to start to define the system behavior elements, specifically states, actions, flows, expressions, and calculations. So not all of those elements are delivered in this release. The other elements will be coming in future releases. All of these different types of SysML, all of these different elements in SysML are strongly interrelated. So for Modeler 10.1, we've implemented action modeling. So we can see graphically some actions shown on a diagram here. And we have the same pattern as we do with other aspects of SysML2 of the usage and definition. The usage item is shown with rounded corners, and the definition item is shown with square corners, and really acts as like a typing mechanism whereby we can specify common features that should be used by other types of that vehicle control in this example. So the usage is an instance really of the definition of which it's typed by. So we can continue to build those inheritance relationships that are common across SysML2 with actions as well. The purpose and the reason to use actions are used to model system processes that describe the functional behavior of the system. So that's the key aspect, really. There are a set of steps that are executed by a system function in a predetermined sequence. So it helps to model the behavior and ensure that the planned design behaves in the correct way and satisfies our requirements and satisfies our design targets. So it enables systems engineers to specify and analyze the behavior of a system in a very detailed way related to the system's design. And then we can define the processes that are used by critical system functions. So let's look in a bit more detail. We can create these new types of elements using the package browser and the context menu at the bottom. But a much nicer way to model is using diagrams and the toolbar across the top. So we'll see a lot of examples using the diagram and graphical notation. One of the key elements in action modeling, as well as the action element itself, is a succession. So it's used to specify the sequencing of the actions, and we can drag and drop the link on the symbols on the diagram to show that flow. Pretty straightforward. We have start and done nodes. So this obviously specifies the start and the end of the action sequence. We have logical operators. So there's a fork, and there's different types of these. So they control really the timing and the flow of different paths through these gates. So in this case, when the start is initiated, all outgoing successions are triggered. So all three get started straight away. Building on that, then we have a join, and the outgoing succession occurs when all its incoming successions are executed. So only when we've completed action 2.1, 2.2, will this join fire, and then action 2.4 will then commence and initiate. We have a decide node, and this allows you to define a guard condition. So you can apply some logic really to control the path that the sequence takes. And we have a merge to bring these types of separate multiple paths together. And the outgoing succession and the action connected occurs when any of the incoming successions occurs. So we just need one path to be fulfilled, and then the sequence will proceed. So there are different ways that you can control the flow. The way that you can control information that flows across different parts of the model are using parameters. So actions own features. So they can own actions themselves, they can have properties, they can have items, and we can model these as parameters. So if it's something that's going to be transferred to another part of the model, then we can model them as a parameter. So we can transfer these parameters to other elements using successions. We see an example at the top using succession, or connection flows. And connection flows give you a little bit more control on the timing of how that transfer occurs. To do this, we create a feature and then specify it has a direction. So the fact that the feature has a direction means that it can then be used to transfer elements to other elements. So in this example, we have a diagnostic check action with a sub-action to check the tire pressure. So this will interact with part of our logical model, a tire sensor that has an action itself to get the tire pressure. So the sequence starts from checking the tire pressure. It then flows to the get tire pressure, which will perform an operation, get a reading, and then it will transfer that reading value using this succession back to the action on the left. So that's just a simple example of how you can transfer and flow items between each other. Here's another example, and we can see now that the action model has been really overlaid and shown within the actual context in which it be defined. So typically it will be defined within a logical structure. So we have a vehicle at the top with some security system components. And then there's a very basic model of an engine with an ECU on the right. So this model is a remote locking system. And we have a key fob with a button, radio frequency transmitter, and then on the vehicle, the central locking system, and then a radio frequency receiver. So the sequence of action starts with pressing a button. This will then transmit a unique identity code from the fob. using a succession in this case, passing it to an action to receive the code and process. It's typically encrypted, so we'll decrypt and verify. And then once we pass, we probably wanted a logic gate here if we failed the verification. But if we pass, then we go on and execute the unlock doors action in the central locking subsystem. So this shows how we can build the different functional behavior, understand the different actions and operations that occur within the context of the larger system and the structure. So let's have a look at a demonstration of some of these feature capabilities. So here are some of the main menus we can see. This is where all of the action modeling capabilities can be accessed. So we'll model the diagnostic system that we saw a moment ago. And we start with some existing parts. So we drag and drop them onto the diagram and then populate some of the members that already exist of that part. So we can see two actions. And then again, we drag another existing part across our diagnostic check, populate the contents of that. And then resize some of the symbols to give us some space to model. So we'll start to model the sequence using the succession element. Now we can add an item. So this is the information or the feature that we're interested in monitoring and assessing. So first of all, we add an item and we can see that's contained by the check tire pressure. When we give it a direction, it converts to a parameter. And with the notation, the symbol notation changes, as you can see. On the left in the package browser, we also display parameters with a prefix, bracket X bracket. So we've done the same on the corresponding get tire pressure action. So we've added a reading item. Now we can add the flow connection to model the transfer of information of that feature between the two actions. And now we'll put a simple side node to provide an alternative path. So in this case, we're going to alert the driver if the tire pressure is below a certain threshold. And we can add successions to complete the flow sequence. Then we can name the kind of path. Into the future, when we implement more of SysML2, this will be an executable model. So we'll be able to put in the logic conditions and then run a simulation based on these behavioral definitions. So that's a really quick demonstration of how you can model, visualize, and then ultimately improve and optimize the system behavior using action modeling with SysML 2.0. So I think that was about 3 minutes to just show a quick, simple model. Okay, some of the other capabilities that we'll get through quite quickly. We can call actions that are defined in another context using perform action. So this allows us to reference actions without having to duplicate them. We have further capabilities planned in this area, so it's not fully implemented at this point. An assignment action is very useful. It allows you to change values of a target. So another model element that has an attribute value of some kind, you can use an assignment to change the value of that. We have send and accept actions, and these are another way to transfer elements to different parts of the model. There doesn't have to be an explicit connection with a flow to do this. So in this case, we can just define the parameters needed, which are the payload, the receiver, and the sender. And then SysML2 is able to understand that as a relationship. We have some loops defined as well. I won't explain in detail each of these, but as you'd expect them to behave, we'd have a while, for loop, and an if action, it is called. So we can apply some logical condition expression to determine the flow of the sequence using this. When you add these types of elements, when you add a for loop, it comes pre-populated with all of these elements to control the logic flow. So it gives you the starting point to define the details of that loop. Here's another example, and this is a vehicle cooling system. And we can see that we have a vehicle on the left with the cooling system elaborated in more detail on the right. And we have some items that are passed the engine coolant using flow connections. So they're passed to the engine, into the cooling system, the thermostat, then via the water pump, through the radiator, back to the thermostat, and then back to the engine. So we can see the flow of elements across the system, and we can see the flow of behavior using the actions. So we start triggering with a manage engine temperature, and then we have a check temperature action that's part of managing coolant flow. So if the temperature is below a certain threshold, then we'll reduce the coolant flow through to the engine. So that will then trigger a reduction in the pump speed. So we can see an example here of how we can show the behavior across the structure of the model again. Okay, the next area of enhancements in 10.2 is around our integrations with our digital engineering products, our digital engineering thread capabilities. So the first feature is a new traceability report. And this is a really useful report to allow users to see the status of connections across tools in the digital thread. So it uses the OSLC standard. So it's based on OSLC links and OSLC surrogates in Modeler. So it provides a summary of any OSLC trace relationships between system and software models in Modeler and any remote data that might be requirements in Codebeamer, RVNS, or DoorsNext, or Polarium. Actually, I think that's incorrect. I don't think DoorsNext works the same way, but Siemens Polarium does work with the traceability reports. And as well as that, Windchill PLM. So we'll describe those in a bit more detail. So the real value in this report is it allows our users to easily visualize relationships between design artifacts. So the systems engineer, the systems model can take a set of requirements and understand which of those requirements have OSLC links and which don't. So the way you execute this is using the OSLC browser within Model. So the first step is to choose a set of OSLC requirement resources. So a set of requirements from Codebeamer or RVNS or Polarium. And then we can choose, do we want to report all the requirements or just a specific subset? So if we want to run a subset, we can build a query to determine the specific requirements included in the report. We can specify an exclusion list. So if you don't want to see things like comments and headings included in the report, you can filter them out. you can save the HTML file for offline viewing and also copy and paste into Excel. So here's an example of a report. At the top, we have the main information, the model source, the provider source, the amount of items that have been included in the reports, the generation time, and the user that generated. So it's organized firstly into sets of columns. On the left, we have all of the requirements that are in scope. So this is a set of RVNS requirements that we selected in the first step. The second set of columns shows any OSLC links or surrogates. So in the top few rows, we can see there are some OSLC links. If it's blank, then there is no relationship between that requirement and anything in the modeler model. On the far right, there's a link to the modeler linked item. So you can very clearly see the requirement, the link, and then the linked systems model item. And obviously the items that don't have links, the requirements that don't have links are highlighted in red in this color, in this case. So it provides a very simple summary that you can understand what requirements have been implemented in the systems model. Can I see those relationships and navigate to them? So depending on the external tool, there'll be a link to jump to that requirement. So it'll take you straight into a web browser to go to that item in RVNS or into Windchill. On the right-hand side, if you click on the link, it'll take you to that model element in the modeler full client. So really nice and easy to use, very easy to understand, and very easy to go and drill down into more details once you've generated the report. So reporting on all requirements, this might get missed. So in this case, we're not going to run a query, but we're just going to basically search for all requirements. So where you trigger the report from in this hierarchy, in this tree, is important. So using this node, we'll get all of the requirements in a Codebeamer context. And then we can obviously save that offline or use it in Excel. Similarly with RVNS, we can generate the traceability reports at this node in the hierarchy. Don't need to create a query, and it just returns them all. And that can be a good way of just understanding the full set of OSLC relationships that you have in a model. So as well as understanding traceability, it will give you a full set of links that you have. Here's an example of copy and paste into Excel and opening the HTML file offline so you can easily share offline and collaborate on the report. Here's an example with Windchill PLM. So this is showing again relationships from modeler items, OSLC links in modeler that are pointing out to a Windchill item. Into the future, we'll need to start thinking about incorporating reverse lookup into this so that we can show links that are in Windchill and show the kind of complete picture across both products. Here's how you can configure the trace reports. You can modify the highlight color, and you can specify the types that are excluded from the reports. This is based on OSLC property. So depending on what the provider, the server, serves up in terms of properties, you can use that to filter out items you don't want. Okay, so here's a demonstration. Hit play. So we start in the OSLC browser and we're accessing a Codebeamer server here. So in this case, we're going to run a query. I'm using the description field. And it's returned a set of requirements. So this is all standard OSLC capability so far, running a query for a set of Codebeamer requirements. We can use that query to create a traceability report for just that set of items. And here we can see the generated report. The main properties at the top, and then the links to all of those Codebeamer items that were chosen. The link to Modeler item. And if we click on that, it'll open Modeler and take us through to that model element. Here's an example looking at parts in Windchill PLM. So again, we're going to run a query. And I'm doing an in search, an in-clause search, and supplying a list of IDs. So this enables you to select exactly the items that you want in your query. In this case, there's 5 parts from a system. So I've run the reports on those, and I can see just that set of parts and any links that they have. Finally, an example with PTC RVNS. And this shows us running the report against all requirements in a project. And we see in this case, we have a large list of items, most of which do not have an OSLC link or surrogate. They're all unsatisfied or unallocated. And same operation for a Codebeamer server. So we can see how this is a nice, simple report, allowing users to understand those cross-tool design dependencies based on OSLC links. And this is an important part of the safety design certification for quite a few of our customers, ensuring that all of the requirements have been satisfied with either systems model or downstream in PLM. Okay, the other enhancement in the OSLC digital thread area is an enhancement to an existing tool that we have called the links editor, the OSLC links editor. So this is used when changes occur to the OSLC links that are stored in Modeler. So it's basically a web URL that points to a resource, and in situations where changes occur on the external server, the target server, maybe the server's been renamed or it's been rehosted or some other internal change that impacts the URL, that then can break the link in Modeler. So this tool provides a way where we can manage those links and, if needed, make changes and modifications to the URL to resolve any issues that are caused by that situation I mentioned a moment ago. So the tool is really important, and it really helps to maintain OSLC links over time. But we really needed to improve the UI and the user experience and help guide the user in a better way. So this new tool, this new user interface does that. It provides a much more guided experience. Instead of having free text fields, it now connects to the external server and understands what valid options, what valid entities are available for selection that can be changed. In terms of links to OSLC Modeler, we can now modify some additional properties. And this is important if you rename models or rename items. So we can rename the model, we can rename the item, the version, and most importantly for all servers, rename the server. So any of these aspects of our URLs can be modified in a controlled manner. And you get previews, and you can very clearly see the difference. So it's much harder to make any mistakes when making changes using this tool. So much better for the user all around. Some of the other capabilities, you can view the OSLC links. So when you open it, it reports all links in a model. You can view the item, you can remove the link, you can test those links. And when you make changes, you'll see the current and the new, which will be chosen from a selection drop-down that shows valid options. So you can preview all of this, and then you can commit once you're finally certain that the changes are valid. Okay, another The next main area of enhancements is around how we deploy our database. So we've changed how we deploy SQL Server. So specifically, this means that we've improved the security and reduced the footprint of our database entities. So instead of installing into the system database, we've now put administration functions into the modeler admin database. So we've got a dedicated location in SQL, which doesn't impact enterprise configurations and settings in the system level. So we're more cleanly segregated than before. And this is obviously a big improvement. It requires an upgrade to the database schema. So customers upgrading from previous versions to 10.1, it requires a very simple database migration. That's initiated from Model Explorer, and it executes automatically. There's obviously a help page. If any assistance is required, please contact PTC support and they'll be able to help. So as well as those schema changes, we've also enhanced the administration features and capabilities and provided a more flexible, tiered, layered administration. So we have new roles that reflect those new administration levels. And we have a system administrator. They can manage all databases, manage logins for SQL, and manage users. And below that, we have an application administrator. So they can manage a specific database. They can manage the users and the access permissions for that database. So we have two levels of administrator now. And the application user is a normal user with access permissions. So we have new user interfaces to set and manage these different permissions and admin roles. And we hope that this will be much easier for our users to manage teams of users and getting the access permissions correct as easily as possible. Another feature that we can now support are the notion of Active Directory forest groups. So this has been able to authenticate against the Windows domains that are not where the modeler server is installed. So it allows us to access across Windows domains and authenticate against users that are stored in those distributed Windows domains. So this was a specific request from one of our customers, but obviously this has usefulness for all Windows environments and large organizations that use Active Directory groups. In the area of simulation, we've improved our support for MathWorks Simulink. So we now support the latest versions of that. That's for synchronizing SysML 1 diagrams and elements for use in simulations in Simulink. SysML 2 will be planned for the future. But for today, this is just updating the existing integration that we have with SysML 1. Another project that we have ongoing is ISO 26262 certification. So this is an ongoing project, and it's based on the final version of the software. So we're still working with the certification organization TÜV SÜD. It's ISO 26262 is a road vehicles functional safety standard for the design of electrical and/or electronic systems that are installed in road vehicles. So PTC Modeler will hopefully be certified as a software tool that can be used on safety critical design projects in accordance with the standard. So essentially, this is a proof and a certification that Modeler performs the capabilities that it claims to do, and that it can support the design of safety critical projects. So this is pending, this is ongoing, and will continue over the next few months as we provide more evidence to TÜV SÜD, and they provide recommendation to us. And then once we provide everything that's required, then we'll get the certification. Okay, so release summary. So first of all, we talked about the rebranding. So from now on, we'll be known as PTC Modeler. We talked about the new phase of SysML2 capabilities around action modeling and enhancements to our existing capabilities in the areas of structure modeling. We talked about the great new capabilities around digital engineering thread with our new requirement traceability reports, and also the fact that it's a part traceability report with Windchill PLM as well. We looked at the OSLC links editor where we can manage and maintain those OSLC links, simulation and support for Simulink. And then we looked and talked about the SQL Server database changes and our new layered administration. And then finally, certification for safety critical design with ISO 26262. Okay, thanks very much for your time, everybody.